Hello, this week we are focusing and starting the seventh grade. We begin with ratios and proportional relationships. I understand that we already know the algorithms, we already know how to do the procedures. However, students today are going to be expected to reason and rationalize through things, explain, talk through things, and using the formula isn't always okay. So I encourage you to have an open mind during this lesson, and just because I present it one way doesn't mean there aren't other ways to present and come up with a solution. So mine is just one way, you may have another way or see things a little differently than I do, which is just fine, which is why in your homeworks I have you explain and thoroughly talk through what you're doing so that I can see your thinking and your thought process. So what we're doing is ratios and proportional thinking again. Um, okay, so a special unit rate is called miles per hour, something you're probably familiar with. 5 miles per hour is one way to say we traveled 5 miles in 1 hour. Jake said I walked 2 miles in half an hour, and Judy said I biked 15 miles in 3 hours. How would you describe their rates using miles per hour? So when I look at Jake, he did 2 miles in half an hour. Well, how much can he do in 1 hour? Well, I know that there are two 1/2s in an hour, so I multiply by 2, which means I would multiply 2 miles times 4 miles. Similarly, Judy biked 15 miles in 3 hours. How can we determine what she did in one particular hour? Well, we could divide by 3, not divide by 2, divide by 3. And if I divided 15 by 3, we would get 5. Happy day. I'm just having a hard time right now, apparently. Okay. So 15 divided by 3 is 5, and 3 divided by 3 is 1. So she biked 3 miles in 1 hour. So let's say Jake and Judy are going for a goal of 3.5 miles in less than an hour. There is a track where one lap is equal to 1/4 of a mile. Here was a trial run. Jake made 2 laps in 7 minutes 30 seconds, and Judy made 2.5 laps in 12 minutes 30 seconds. Are they on track to complete their goal? So we're going to use a double line graph here to help us determine what we know. So we know that Jake made 2 laps in 7.5 minutes. So 1 lap is equivalent to 1/4 of a mile. So 2 laps would be 1/2 a mile. So then if he went another 7.5 minutes, he would have made a full mile. And we can continue this. Another 7.5 minutes would be 1.5 miles. 30 minutes would be 2 miles. 37.5 minutes would be 2.5, all the way to 3 miles. And he would need 45 minutes to do 3 miles and 52.5 miles, or excuse me, 52.5 minutes to complete 3.5 miles. So he is 7.5 minutes away from the 3.5 mile requirement. So I would say that Jake is on track to finishing the goal if he were to keep the same pace. Let's talk about Judy a little bit. So Judy made 2.5 laps in 12 minutes and 30 seconds. So if 1/4 of a lap, excuse me, 1/4 of a mile is 1 lap, so we ask ourselves how many halves are in 2.5 laps. So Judy ran 1/2 a lap 5 times in 12.5 minutes. How long did it take her to do each lap? Well, 12.5 minutes divided by 5 laps is equal to 25 halves times 1/5, which is 2 5/10, or 2.5 minutes per half lap. We then know she does 1 lap every 5 minutes. Then 2 laps she can do in 10 minutes, 3 laps in 15 minutes, and 4 laps in 20 minutes. 4 laps is 1 full mile. So Judy can go 1 mile in 20 minutes. That also means that every 10 minutes she can extend a half a mile. So it would take her 70 minutes to go 3.5 miles. Judy will need to get faster if she wants to reach the goal. So we can use a double number line to think about proportional relationships between two different types of units, such as miles and hours. When units and proportional relationships are different, we can use a double number line to reason about their relationship. Let's say we are at the market and that 1 pound of cheese is $3. If 1 pound of cheese is $3, we can reason or double that 6 pounds would be $2. Or dividing it in half, a half a pound would be $1.50. So each half pound we extend $1.50. Further, what if I wanted 87 hundredths of a pound? How much money would that cost me? We know it has to be between $1.50 and $3 because of where it lands on the double bar line. So I can take 87 hundredths times $3 and it would cost me $2.61. But what if we wanted to spend a specific dollar amount on cheese, such as I want to spend $7. How much cheese can we get for $7? Well, we know that it must be between 2 and 2.5 pounds. Well, I know that I can get 1/3 of a pound for $1, 2/3 of a pound for $2, and 3/3 or a full pound for $3. So when I look at the particular piece per unit, what I can do then is take 1/3 times 7, which is 7/3, or 2 1/3 pounds. When units in a proportional relationship are different, we can use a double number line to reason about the relationship. Use a double number line to show how much 8/10 of a kilogram of bananas cost, if we know that 3 kilograms of bananas is $2.40. Well, I can reason that 1 kilogram would cost 80 cents by dividing $2.40 into 3 parts. Further, I know that 8/10 divided by 10, or 80 cents divided by 10, is 8 cents, or 10/10 of a kilogram. Then I can reason back towards the 3 by saying that 1/10 times 8 is 8/10 of a kilogram, and 8 cents times 8 is 64. So therefore, 8/10 of a kilogram of bananas would cost us 64 cents. By using kilograms and grams, we know that by moving up and down the number line, we can use powers of 10 to do so. Willy Wonka's candy shop sells candy by the ounce. There are 45 cents for 6 ounces of chocolate bites, 50 cents for 8 ounces of miniatures, and 60 cents for 10 ounces of tartlets. Which candy will you get the most of if you buy $5 worth of one type of candy? So I'm going to use a triple bar line or triple number line. The top one is chocolate bites, the middle one is miniatures, the bottom one is tartlets, and then overall cost, so we can kind of keep an eye on what we're doing. I'm going to start with the miniatures just because I can reason that 50 cents times 16 is 8. No matter how much money I have, this will stay the same. So it's going to stay in proportion the whole time. So if I were to take 50 cents, multiply it by 16, I get 8. So no matter what I have, if I multiply it by 16, it'll give me the number of ounces that I have. Further, what I can do is take 50 cents times 2 to get $1, and 8 times 16, or 8 times 2 to get 16. So now I have a unit. So for every dollar is 16 ounces. So $2 is 32, $4 is 64, and I know that for every dollar I gain 16 ounces, so 64 plus 16 is 80, and 4 plus 1 is 5. So for $5, I get exactly 80 ounces. Now I'm going to move on to the tartlets. I can multiply 60 cents by 5 to get $3. And 10 ounces times 5 is 50 ounces, so right here. Then I'll count up, so $3.60 will give me 60 ounces. So I'll count up by 60 cents and add 10 more ounces. That will bring me to $4.20 will give me 70 ounces, and $4.80 will give me 80 ounces. So at this point, tartlets for $5, I can still I'll be able to get more tartlets because for only $4.80 I can get 80 ounces, whereas the miniatures I had $5 and that gave me 80 ounces. I still have 20 cents left to go. So what we can do then is say, well, I have $5 the same as 500 pennies. So if I divide that by 60 pennies, gets me about 8.3 pennies per ounce. So I need to go a little bit further. So 8.3 times 10 is 83. So 83 ounces for $5. So right now the tartlets are a slightly better deal. What about the chocolate bites? If we take 45 cents times 10, that'll give us $4.50. Further, 6 ounces times 10 is 60 ounces. So for $4.50, we get 60 ounces. Then we can go ahead and count by ounce, by 6 ounces. So if I add 45 cents, I'll be at $4.95. Add 6 more ounces, I'll be at 66. I can see from this moment on that I'm not going to be anywhere near 80 ounces. I'm only at 66 ounces and I still have 5 cents to go. So I can rest assured then that the tartlets are the way better deal. We can write equations to show how two quantities change together in the same way. Write an equation that relates the number of students, S, to the total cost of the trip, C. So 72 students is $1,188, 86 students is as follows, and then 92 students. Well, we need to find out the cost per student. So we can take $1,188 divided by 72 students. We see that it's $16.50 per student. Further, that should be the same, I would hope, when I do 1,419 divided by 86 students to get $16.50. So if the costs were to remain the same, we can take the number of students going on the trip, multiply it by 1,650 and find the total cost. So let's try that out to make sure my theory works. If I have 92 students and I take that times 1,650, I sure enough get $1,518. So this works. So 1,650 times the number of students equals the cost. We can also reason with the different properties of multiplication and division. So we could do the inverse of multiplication and divide each side by S. So cost divided by students is 1,650, which is what we did up here. Or another equivalent one would be cost divided by 1,650 would give us the number of students that we have. So there's 3 different ways that we could represent this. It just depends upon the context of the problem which it's asking us for the ones that we should, for the type of equation we should use.